So in the previous session, we have arrived at a final equation of a perceptron output, right? So this is the output of a perceptron, like how the mathematical processing takes place within a perceptron. So it is just a cumulative sum of inputs along with the weight associated with it plus the bias term. So this is how a particular output of any perceptron will look like. And we have also arrived at the census of these output equation, that is, if a cumulative sum of the input is greater than 0, what it is, and if it is equals to 1, what it is. So yeah, so this is what we arrived in the previous session. So in this session we will start something top of the perceptron. That is, we started this discussion in order to build a artificial neural network, and we inspired the concepts from the actual human neuron. Then we studied one individual structure of the human brain, that is neuron, and we try to build our own artificial neuron, that is perceptron, right? So with an understanding of the perceptrons, we are now equipped to study the design of artificial neural network. So a neural network, either it may be a biological neural network or an artificial neural network, it's just a collection of those small functional units. If it is a biological neural network, then those functional units are called as neurons. But if it is an artificial neural network, then those individual functional units are also called as perceptrons. So the neural networks are collection of artificial neurons arranged in a particular structure. This is very much important. The neural network is not just a random structure. They are the structure which are arranged in a particular manner or particular fashion in order to get the task done, right? Right, even in the human brain also, it follows a certain structure or a topology in order to convert the signals or the input signals into the specific output signal. So how an artificial neuron works, that is how it converts inputs to outputs, we will also understand the topology of the structure of the large neural networks will look like. So we'll study this entire thing, like how to unify or combine these individual structures called perceptron to build one such large neural network in order to perform any task, literally any task, in order to classify the elements or in order to come at a one point decision, etc. So we will study about how to combine these neural networks, what are all the inputs, outputs, etc. in the following session. So yeah, now we will begin with arranging the neurons to build a network. So we studied this is how individual perceptron will look like. To reiterate on that, this is a perceptron or a neuron. It has different inputs with weight associated with it, that is W1 and W2, W3, etc. and output with a activation. So these inputs might be coming from other set of neurons as well, and these neurons receive inputs from other neurons as well. So suppose if you want to neglect or ignore this input coming from this particular neuron, the simple step would be to reduce or equalize this weight associated with that input equals to 0. Then we are ignoring this input from the particular neuron. So this is how a particular neural network will be looking like. It is a small zoomed part of a one such large network. So suppose if you take a very complex neural network, it will be consisting of these structures which are internally connected to one another with certain weight associated with each other. So there are different fashion or there are ways in order to arrange these neurons. We can arrange this in this way, or you can arrange this with another approach in order to do certain task or in order to conduct certain tasks to get the specific output. So the topology of a neural network is the like neurons in a neural networks are arranged in layers. See, this is one layer, this is the second layer, right? This we can call this as layer 1 and layer 2. So we arrange these neurons in layers. We arrange these in layers together in order to form a one complex neural network. So the neurons in a neural network are arranged in layers. The first and the last layer are called as input and output layer. So for this given specific example which I am demonstrating, we can take this as an input layer and we can take this as an output layer. So the input layer consisted of two perceptron and the output layer consists of one perceptron. So the input layer receives the signals from the external world or other set of neurons say, but since we have taken this as an input layer, it will be receiving the signals from the external world. Let us consider as teaching a child to learn that the particular picture is a dog, right? So we are iterating back on that example. Then these are the set of neurons present just exactly behind our eyes. Okay, so that will be the input layer. So this input layer just behind the eyes will receive the signals picturizing about a dog, right? So it will receive those light signals and these input signals are processed by the input layer based on certain processing or applying certain mathematical equation which we decide or which we have arrived at in particular in the previous session. So these particular operations will be conducted internally and it will give certain output. Then these set of neurons or these set of signals passed from the previous neurons will be get back to the output layer. So the output layer would be present in the brain or it might be to another device. So for example, I have received this input signal from the eyes, those are processed, and if I want to say that the picture which I just saw is a dog, so then the output would be my mouth. So these set of neurons would be present just before the mouth. So in order to say that or spell out that picture which I just saw will be decided from this output layer, and this output layer is activated based on the certain signals received before. So the activation of this output layer is decided by certain input signals, right? So this is how a simple neural network will look like. In order to reiterate on that, it receives the input signal from the external world, it will process or it will decide what those input signals are, and it will send back or the send back decision or unified decision from the two different neurons to the one output neuron or a perceptron to decide what that particular picture is about or what these external signals are about. So the topology in the neural networks are arranged in layers. The first and the last layer are called as input and output layers. Layers have as many neurons as the number of attributes in the data set. So coming to the data set, so a input layer will be consisting of those many number of neurons as much as the number of data points present in the input data set, and the output layer has as many neurons as the number of classes of the target variable. So we can build or we can classify the structure or the topology of the arrangement of the neurons into two different classes or two different types on a high level. So one, either to perform a classification task or to perform a regression task. So what would be the difference between these two? So say now I have given with 10 different colors, right? So I have given with 10 different colors. Now my task is to classify these colors accordingly. I have to classify this into red, into yellow, into green, etc. So then this task, when we approach a machine to do this task, then we probably end up with a neural network which has, say, the input signals would be 10 different colors, right? So the input neurons will be 10 different neurons or 10 neurons. Then the output would also be 10 neurons, right? It should either to classify each and every color to one of the classes, right? So the input, if the number of input signals or number of input neurons are equals to number of output signals or the number of output neurons, then that would be topology for classification problem. Got it? So suppose I have given a structure or an element or a block or any object, and now my task is to identify what is that object. And in order to identify what is that one single object, I have some different input signals. Say I have given a mobile phone. So now in order to identify that this particular object is a mobile phone, then I need to process certain input signals, right? I have to see the structure of the object. Okay, it is some 4.6 inches, it has camera, we can able to make a call with it can produce an output sound, and it has a charging facility, etc. So these will be the set of input signals, right? But after processing all those different input signals, we will be arriving at one output. That one output would be identification of that particular object, right? So I at the end, whatever the number of input signals you have processed, the end task is to identify what is this object is particular. So after processing that, okay, I have seen this has a camera, screen, input charging signal, etc. I will be arriving at a one single common decision, that is, it is a mobile phone. Then in that case, the topology would be exactly similar to this. So it has multiple inputs, but we have only one output signal or one perceptron to decide either the object, what is that object is just about, right? So we have to arrive one common decision or one final output, that what is that particular object is about. Then that topology would be called as regression topology. So the regression problem, the number of neurons in the output layer would be one, a numerical way, right? That is one, only one neuron. So let's have a look at two different arrangement or topology as mentioned above. So we'll have a pictorial representation of these two topology which we just discussed about.